Get these proofs from, you can look on Ngrade. Maybe I'll send it with your in an email as well. But it'll be on Ngrade on the calendar for May 18th, thereabouts. It'll be on there so you can print them out. You probably should print them out so you'll have them. Some of them I just put the figures on what you're supposed to prove. I found a flaw in this proof. I'll show you what it is. It's kind of funny. Every now and then a book will do something they've been teaching you not to do. And I don't know who wrote this proof, I guess. Anyway, it's kind of funny. Okay, it says XYZ is a right triangle. Remember, I would like you to mark on your proofs. It's a right triangle. XYZ is the right angle. And then we've got VW is parallel to XY. And YU is an altitude of XYZ. And then you need to look at what we're trying to prove. Okay, let me get some color here. We're trying to prove that YUZ is congruent to VWZ. Actually, maybe they don't have a flaw here. I was first looking at it, VWZ. So maybe not so much. I think I had misread the problem. All right. So XYZ, triangle XYZ is a right triangle with altitude YU. Now, you look at this and you remember you've got we're dealing with triangles. So this has been for a little while ago. But we've done a lot of proofs using triangles. That's why the proof on the test, at least one of the choices that you'll have will be a triangle proof. You get to choose between three. You don't need to do all three. You just need to do one of them. Okay, we're looking at a right triangle, and we have an altitude of that right triangle. So that's important to remember. And we're starting with this kind of proof that has the statements, so all you have to do is justify them. Okay, it says XYZ is a right triangle with altitude YU. You get a different color. And that's right here. XYZ is a right triangle with an altitude of YU. So that is given. Okay. XYZ is congruent to YUZ. Let's mark that over here so we can see what we're looking at. We'll use a different color than what we've used so far. XYZ is a triangle, and it is congruent to YUZ, or not similar, I'm sorry, not congruent, but similar to YUZ. Let's use purple. Oh, we have YUZ, it's in cyan right there. YUZ. Okay, now why is that? Now, I don't know if you wrote this on your theorem list, but it's that one that tells us when we have a right triangle. And we learned that all three of these triangles are similar. This one is similar to this one, which is similar to the whole thing. We could maybe call it the right triangle, the similar right triangles. They're not congruent, they're similar. I don't know what I keep saying, but I mean to say similar. Okay, so you could use the similar right triangle similarities or similar right triangles theorem. You'd have to call it similar right triangles theorem with the altitude. That's important. The fact that this altitude has been drawn here is what makes these three triangles similar to each other. All three of them. The big one, the little ones. They're all similar. Okay, so we'll get some of that junk out of there that I just put in there. Okay, so I'm going to call it the similar right triangles theorem. Similar right triangles with altitude theorem. Similar right triangles with altitude. Not to be confused with attitude theorem. Okay, it's really in your book on page 449. I looked it up because I knew you'd be like, where is that? Okay. In reality, if you did not have a theorem list, you would be sitting there saying, now how am I going to say that? And you might have had to write a statement similar to, you might have said, oh, if you have a right triangle and you have an altitude that goes to its hypotenuse, that altitude will divide that triangle into two similar triangles that are similar to each other and similar to the large one. But I don't exactly have enough space to write that. Okay, VW is parallel to XY. How do we know that? right here. It's given. Given. All right, now, VWZ is congruent to XYZ. So I'm going to mark these with a arc. VWZ. VWZ is congruent. VWZ is congruent to XYZ. Oh, okay. I had to figure out why that was. All right. Well, we have some parallel lines here, and this has a right angle right here. Oops. I should be playing Words with Friends with somebody. I'm sure somebody's annoyed with me. Probably Edie. No, Edie's never annoyed with me. Okay, I have two parallel lines, and this one's at a right angle, and it says if a line, how does that go? If one of two parallel lines is perpendicular to a third line, then the other one is also perpendicular to the third one. You could call them corresponding angles theorem, because that would be corresponding angles too. We'll call it the corresponding angles theorem because that's short. Corresponding, let's see, if lines are parallel, corresponding angles are congruent, right? And we need this if lines are parallel, right? All right, number 5. Z is congruent to Z. Oh, that's a tough one. Z is congruent to Z. Could be reflexive. Some of you might want to call that identity, but it's not. It's reflexive. Okay, now. Okay, something by the angle-angle similarity postulate. Well, let's see. I just marked, let me do this with some highlighter. I'll do it in purple highlighter. I just marked a right angle here and a right angle here and an angle here. And those both pertain to this triangle and this triangle. So when I talk about angle-angle similarity, that's going to have to do with a couple of triangles, and the two angles have in common that big triangle and that small triangle. So it would need to be triangle XYZ is similar to triangle VWZ by angle-angle. Okay. Triangle XYZ is similar. Here's XYZ to VWZ, to triangle VWZ by the angle-angle similarity postulate. All right, now we've got YUZ is similar to VWZ. Well, you always look at the step right ahead of you to figure that out. So this one looks like that. It's the same. Well, that makes me think, okay, what relationship do these have? When I go up here, I see that right there. So if this, get something a little bit stronger to talk with. If this one is similar to this one, and this one is similar to this one, then this must be similar to that. Well, I did that kind of backwards. Let me try that again. Is similar from up here to XYZ. Do that in a different color. To XYZ. That's right there. And XYZ is similar to VWZ. Then YUZ is similar to VWZ. think I'll just leave it there for a second. Okay,